Yeah, so the recording has started. So, Susan, did you submit the assignment?
Yes, yes, yesterday at 11 p.m.
Okay, but for some reason, like I'm not able to download it. Whenever I'm trying to download it, it's showing that, a 404 error. So, maybe I'll get in touch with them. But before that, would you be able to share that with me here in the chat? Do you have that option?
Yeah, let me see.
Sure.
Shall I email it to you?
That would be good also.
Okay.
Or even like if you can just share your screen and open that
Yeah.
file, so that would also work.
Okay.
Yeah.
How do we share screen? Just a minute.
So are you joining from laptop or you're joining from mobile?
Yeah, laptop.
Okay, okay. Yeah, you have shared the screen. Okay, so
On my end, it shows uploaded and completed.
okay, from my end also it's showing uploaded, but I'm not able to download the file. There's an issue. Okay, no issues. We can check it from here only. Um, what's the difference? Okay, so now as you have written that, okay, just scroll up a bit. Yeah, yeah, for that, the high priority, low severity example. So there, if you have written that if the logo of a business has a spelling mistake and this does not affect the buying capacity or functionality. So your example is correct, but what you need to describe here is why it's a high priority bug and it's a low severity bug, right? So here, why it's low severity, that you need to mention. So you need to mention that this is not affecting the um like the functionality of the system, right? So that
I
also you
thought
need to
I
mention.
thought I added it there, and this does not affect the buying capacity or functionality. It's in the same sentence.
Okay, so if the logo of a business has a spelling mistake, yeah, and apart from that, you need to also mention that, but this has to be fixed as soon as possible by the developer, because this might affect the branding of the company. So that's why it's a high priority defect. So that also you need
Okay.
to add.
Okay.
And low priority and high severity when the user uses a
I
very
thought it was
minor
just
feature.
an example. I will add it next time.
No, it's fine. It's fine. I'm just because nowhere you need to write this kind of things. They will only ask this kind of questions in the interview. So in the
Okay.
interview, it will be better if you can express yourself, your knowledge, right? So that
Mm-hmm.
would be an added advantage. So whatever you know, just express that. So that will be my suggestion.
Yeah.
Okay, when the user uses a very minor feature of an application and this causes application to crash. Yeah, here also, like you need to mention that as this is affecting uh, the application, the functionality of the application, so that's why it's a high severity defect. But as
Mm-hmm.
very few users are going to use that, or it's a very minor feature, So that's why it can be resolved by the developer in a later stage. So that's why it's a low
Mhm.
priority. You don't need to write
Mhm.
here, but if the if the interviewer is asking you such questions, just explain that to him or her so that he or she knows that you know the basics. The basics are clear to you. Okay. Okay. Fine. Yeah. You can close that, and thank you for completing that.
You're
I will
welcome.
just share my screen. Hope my screen is visible.
Yeah, yeah.
Okay. So before we proceed, any queries from yesterday's class?
Uh, just a minute. No, no.
No, right? I mean, the basics of all the four software development model that we studied yesterday. So those are clear. I mean, you can, if someone asks you, you can recall the representation or the diagram of that particular model, and you can explain
Mhm.
that to them, right?
Yeah.
Okay, that's great. So there are a few more models which are present, and we are going to talk about those today. Okay. So
Mhm.
what are the topics that we are going to cover today? So there are a few models which are basically RAD model, prototype model, spiral model, and agile model. So this agile model is somewhere like something like the mix of the incremental model and the iterative model, and this is widely used in recent time. Okay,
Mhm.
almost all the companies or all the projects are using this agile model. Apart from that, this RAD model, prototype model, and spiral model is also there, but I would say that these are uh, more like theoretical concept. Okay, this
Mhm.
prototype
Mhm.
model is somewhere used, but it is not widely used as well. It's like
Mhm.
whenever the project is in initiation phase, right? I
Mhm.
mean, the project has not come to the company yet. I mean, a lot of companies are bidding for the project, so that's when they make a prototype of the project and demo it to the customer so that the customer is and so the customer can be onboarded. So in those cases this prototype model is used, but after the contract is signed, I think most of the companies will use this agile model itself. And these models are kind of like theoretical model. And one more thing is these are not very much important uh, from the interview perspective as well.
Mhm.
You need to remember somewhere this spiral model, because they might ask you what is spiral model. But apart from that, this RAD model and prototype model, so this is just required, just good to know. And if somewhere in the interview they ask, you can answer it, so you should be in that
Mhm.
position.
Mhm.
Otherwise these are more often like the theoretical concept, and those are not widely used as well. Okay.
Mhm.
So let's see what is RAD model. So RAD model is basically a rapid application development model. Okay. So what does it mean? So it is a type of incremental model. Okay, it is the extension of incremental model, you can say. And in RAD model, the components or functions are developed in parallel. So we saw in the incremental model, if you remember the diagram, what was that? an incremental model, what were we doing?
Uh, in model, the modules are divided and in incremental stages it is used, I think. Um,
So the requirement was initially divided, right, into
mhm.
different builds or
Yeah,
modules,
yeah,
and then those modules were being developed parallelly, right?
yeah.
Okay, so this is the concept is same here, as it is a type of incremental model. In RAD model, the components or functions are developed in parallel as if they were mini projects. So in incremental model also we were seeing that the requirement was, divided into several builds, and those builds were having its own waterfall model, right?
Uh-huh. Yeah.
Yeah. So we can say that those are itself a mini project, those builds, right? Because
Mhm.
those are being developed independently. So those are itself a mini project, which will be integrated once those are built. So the developments are time boxed, delivered, and then assembled into a working prototype. This can quickly give us the customer something to see, and they can provide the feedback regarding the delivery and the requirements. So basically, if we have some limitation with the time, and we need to develop something very rapidly and quickly, so in that case we can follow this RAD model. So what's different here from the incremental model? So that you can see in the diagram which is given below. You don't need to remember it. I would repeat again, you don't need to remember it. Just
Mhm.
understand what is there. So
Mhm.
it might see a bit confusing, but you don't need to remember it. Just understand what is happening here. So first, what will be done? Business modeling will be done. So on basis of flow of information and distribution between various business channels, the product is designed. So take example of again Amazon.com. Okay. So in case of Amazon.com, first what will be done if we are following the RAD model? We'll try to understand the flow of information with respect to business, their
Mhm.
business channel. We try to find out the flow of information. After that, what will be done? The data modeling will be done. Based on the information collected from business modeling, we'd see that how the data objects are flowing. Okay, so you don't need to remember it in that way. Just focus that, okay, first the business modeling, like if the customer or if the client, or if the user, rather, if we say if the user is trying to use Amazon.com, what what business flows he needs to follow. So from that model we'll get a data model. Okay, then the user has to log in. Then from login he will go to the home page, and there he will search his product. If not, then we'll showcase our product there, and when he'll select a product, we'll show the product details page to him. So this is kind of the data flow, right? So this
Mhm.
data flow has to be found from the business modeling. So after that is found, then the process modeling will be done. Again, you don't need to remember all this. This is just for the understanding. If someone will ask you what is RAD model, if you tell them that okay, RAD model is rapid application development model, which is an extension of incremental model. And what it is done here, that we will develop the builds in parallel once the requirement is divided into several builds, and these builds will be developed in parallel, and this will be treated as mini projects. That is enough. You don't need to remember all this, but just for the information or learning, uh, just for the learning, you can just uh, read this through. So after that, the data object that is declared in the data modeling phase is transformed to achieve the information flow necessary to implement a business function. Again, the flow is derived first. So the requirement, we are trying to understand the requirement and bring it to the. So this is also will be done by the development team itself. You don't need to get involved in this if you are in a RAD model. But just for the sake of information, we are reading this. So after that, what will be done? The application modeling will be done. And what is done here in the application modeling? The coding and all, the development is done by some of the automated coding softwares. And that's why the usage of this RAD model requires more knowledgeable resources, and it's a bit costly as well. So automated tools are used for the construction of the software to convert process and data models into prototype. So whatever models we are developing, from the business model, from the data model and the process model, whatever information is coming, so this thing you can remember, and if you say, that will be cherry on the cake, that okay, in case of RAD model, the automated tools are used to convert the data and the application to code, right? Did you get
Mm-hmm.
the point?
Yes, yes.
Yes, so automated tools are used for the construction of the software to convert process and data models into prototype. So that is the application modeling. After that, it will be tested during the iteration, and the overall testing time is reduced in the RAD, again because we are developing each build separately, and all the builds will be tested in parallel. So that's why it reduces the overall testing time as well. Okay.
One question. So
Yeah.
you said automated tools are used, which means we don't need manual testers here.
No. Automated tools means it's not for the testing; it's for the development. I mean, from the data and information that we are gathering from these models. So from this, those models will be given to a automated software, which will develop the code for you. So it will develop this application for you. It's not going to test your application. The testing you need to do in the next phase, which is testing and turnover.
Okay.
Okay. So let's see what are the some of the advantages and disadvantages. And this is almost similar to incremental model, but there are some specific points which are there, because there is a scope of this automation software building tool. So due to that, the advantage is reduced development time. So the first one, the reduced development time is basically we are introducing this automated softwares and tools which will develop the software. So that will reduce the overall development time. It increases the reusability of components. Why does it increase the reusability of component? Because the models we are developing, so those data and information will be uh, you know uh, uh, um, will be handy, and we can use those for, if there is any similar component, so we can develop that using those models. Then quick initial reviews occur as we are building the product. So whenever you are uh, getting anything that tells you that okay, we are building the prototype here, so that means we'll get a initial review. Whenever the prototype will be built, it will be shown or demoed to the customer, and we'll get the initial review. So initial review will always help you to understand, or for changing the requirement, or get the initial feedback, and in the next iteration we can change accordingly, according to the feedback. Encourages customer feedback, exactly the same point. And finally, integration from very beginning solves a lot of integration issues. So what was happening in case of the waterfall model and all the uh, software builds were getting developed, and after that everything was getting integrated at once. But here what's happening, that all the requirement is divided into several builds, and once the prototype of those builds are getting generated, we are integrating them and we are testing them. After that we are, so that is one prototype that is getting built. After that we are following the iterations and developing on top of that, right? So that that's why the integration is happening from very beginning, which solves a lot of integration issue. If we perform the integration in the latter stage, so that might give us a lot of issues. But here, if we get those issues at the initial stage, we'll be able to solve those in the initial stage only. So these are some of the advantages of RAD model, and some
So
of the
one question.
yeah, yeah.
So is waterfall the only one in which integration happens at the end? I mean, my question is
Yes, waterfall model, and along with the waterfall model, we had another model, if you remember, the extension of
the V,
waterfall model.
the V model waterfall.
Yes, yes. In the V model also, the integration is done at the end. After everything is developed,
Okay.
then only the integration is done. Because if
Mm-hmm.
you remember correctly, in waterfall model and the V model, both were sequential model, right?
Mm-hmm.
So whenever you are following any sequential model, you can only go to a certain stage when all the previous stages are completed.
Mm-hmm.
So that is one disadvantage of like the sequential models, like the waterfall model or the V model.
Okay.
Okay. But in case of this incremental model, or say the iterative model, or the models that we are going to see today, so in these cases, the goal is to develop develop a prototype first, right? So whenever you are
Mm-hmm.
trying to develop a prototype, in that case you need to integrate those small builds together, and then only you can demo it to the customer. So that's why
Mm-hmm.
the integration starts from very beginning in all these models.
Okay.
Okay. Cool. So, what are the disadvantages? So, disadvantages are depends on strong team and individual performance for identifying the business requirements. Because here we had already seen that some of the models are getting developed, the business models, the data models, the process models. So, these are the different models that we are trying to generate from the requirement. So, generating those models requires very strong team and a very knowledgeable team as well, right? So that is one
Yeah.
disadvantage here. The next one is only system that can be modularized can be built using that. So this is also like applicable for uh, incremental model, right? Because if you
Mm-hmm. Mm-hmm.
can't break the requirement into several modules or several builds, then those
Mm-hmm.
can't be developed parallelly, right?
Mm-hmm.
So those can't be built parallelly. So that's why, if like if we can't divide the uh, requirement or modularize the requirement, then we won't be able to use RAD model or say incremental model as well. Now it requires highly skilled developers or designers, because if developers are not committed to delivering software on time, RAD projects can fail. The motto or the core of the RAD project, or the name also, it's suggesting rapid application development. So it has very less time, you know for delivering the project. So that's why it requires highly skilled developers or designers as well. And
Mm-hmm.
finally, inapplicable to cheaper projects, as cost of modeling and automated code generation is very high. So this is also understandable, because
Okay.
it requires the cost of modeling, and also this automated code generation, and also like the developers that is required to follow this model. So those are also highly skilled developers or designers, which will require more cost to the project. So if the overall cost of the project is less, in that case we can't go with the RD model.
Mm-hmm.
So my question to you now, as like we are already following, when we can use RAD model, what do you think? I think we have
When
already
you need,
discussed.
we can use it for a quick something a quick application that you need to develop, provided
Hmm.
you have the financial thing. You should have highly skilled developers. You should be able to make it into modules to develop it, and then it's going to be expensive.
Yeah, so
And
you should have the budget as well.
yeah,
So see, you don't need to go through the slide as well, right? If I mean, I am almost 99.9% sure that no one is going to ask you this RAD model. But even someone asks you, and if you remember the concept, you'll be able to answer from there itself.
Mhm.
So RADs should be used only when a system can be modularized. So if a system can be modularized, then we can use the RAD model. Then
Mhm.
it should be used if there is a high availability of designers for modeling, obviously, as there are different modules, modelings, right? The business modeling, the data modeling, the process modeling. So we need high availability of designers there. Then it should be used only if the budget permits use of automated code generating tools, because we are going to use the automated code generating tools, which is going to cost us. So that's why the budget should be there. An RAD STLC model should be chosen only if domain experts are available with relevant business knowledge, because for that modeling purposes, we need a lot of in-depth business knowledge. So the domain experts are also required here, and should be used where the requirements change during the project and working prototypes are to be presented to customer in small iteration of 2-3 months. So the development time is less. And obviously, I mean, whenever we are following this incremental model or iterative model, the prototypes will be uh, you know demoed to the customer. So these are the cases when we can use RAD model. So for the RAD model, the first thing is you need to remember two, three things. If you remember for RAD model, that will be enough. I guess four things. The first one is it's the extension of incremental model, where we will divide the requirement into several builds, and those will be um, developed in parallel. Okay, so that is the
Mhm.
first point. The second point is there are different modelings that will be done. If you remember the names, that is good. First the business model, then the uh, data model, and then the process model. If you don't, that's also fine. That's also fine. If you don't remember, just remember that there are some modelings which are involved there. Data modeling that is involved there in RAD model. Okay, so those modelings will require highly skilled developers and designers. This is the second point that you need to remember. The third point that you need to remember is basically automated coding softwares are used here to write the coding and develop the software, which also requires high cost. And last one is once this prototypes are developed, those are integrated and demoed to the customer. This is all you need to remember for RAD model. Okay, any query from here?
Now, what was the last point? The prototypes are developed mean.
So prototypes is basically what we are already discussing, right? That when the software will
Yeah,
be
yeah,
yeah, the prototype will be developed first and it will be demoed to the customer, and based on the feedback that we are receiving or the review comments that we are receiving from the customer, based on that we will uh, develop on top of that.
yeah. Okay.
Okay. So now the model itself says the prototype model. So I don't think I need to explain anything here. You already know what is a prototype, and from the diagram itself, you would be able to understand what is happening here. So let's take a look at the diagram first, and then we'll go to the text part. So initiation, the project initiation is happening. What will be done after the project initiation? Obviously the requirement gathering. You need to understand the requirement, you need to gather the requirement. After that, what will be done? The objectives will be found, then the prototype will be developed. The after the prototype is developed, we'll test that, we'll demo it to the customer. Then until the product is developed, this process will be there in a cycle. And after that, the production, once the whole software is ready, it will go to the production. So this looks similar, I guess, to which model?
The waterfall model.
No, in waterfall model we can't go back to previous stage, right? But here we are
Hmm.
again going back to the previous, and that this is not sequential model as well, right?
Okay.
So this is
Uh-huh.
similar to iterative model, if you remember.
Iterative. Uh-huh.
Yeah, in the iterative model we were going back to the previous stages, and it's like an iterations were happening until the end product is developed. If you can just open the diagram of iterative model, I think that will be better. I'm just asking you because
Yeah.
if you look at the diagrams a lot of times, it will be easy for you to remember.
Yeah. Yeah. I got it.
So do you want me to open it, or you have those
No, no,
handy?
I got it. I got it. I got it on my
Okay,
phone.
okay, good. So if you look at the iterative model, it's going back to different iterations, right?
Yeah.
So something similar is happening here as well. What's happening here? Basically, we are developing the prototype first.
Mm-hmm.
So prototype is a working model of software with some limited functionality. Obviously, when you are first time developing it, the prototype won't have all the functionality because you are just developing some of the features and developing the prototype. You are showing it to the customer. If they're happy with that, then on top of that you are going to add more features on that, right? So it's not going
Mm-hmm.
to initially it will have limited functionality, and over the time all the functionalities will be integrated there, and when it will have all the functionalities present, we'll deploy it and it will go to the production.
Mm-hmm.
So the prototype does not always hold the exact logic used in the actual software application, and it is an extra effort to be considered under effort estimation. So this is something that you need to understand, that prototype model is not always the software development model which is used in the project. So as I was telling you that it's sometimes it happens that before we start actually working on the product development or the development of the software, we first do a kind of proof of concept or POC. Okay, so there we try to develop something which is similar to the exact software that we are trying to develop. So it will have some logic or some features, and we can show it to the customer that see, we have the capability of developing the software, but here we have not developed everything. We have just developed some of it, and just to show you that we can develop it, and from here we will go to the actual development of the software.
Mm-hmm.
Okay, so that's why it requires extra effort to be considered under effort estimation, because we are not developing the actual software here. We are developing a prototype first, we are demoing it, and after that we will actually develop the software. So prototyping is used to allow the users evaluate developer proposals and try them out before implementation. So before the implementation of actual software, we develop the prototype to evaluate. I mean, so see, what happens actually is, I will just tell you the examples. So when we get the requirement from the user, okay, so we do the requirement analysis, and once the requirement analysis is done, I'm telling you from the developer's perspective, okay? So you don't need to remember anything from here, it's just like for your knowledge. So what happens when we get, after the requirement analysis is done from the developer side, so they sit, all the developers and the architects and the business analyst and all, so they try to uh, do some POCs. You understand what is POC, right? Proof of
Plan
concept.
of, yeah, plan of
Yeah,
consent.
yeah, proof of concept also you can say
Okay.
it. So basically, several architects or developers might give several suggestions, or there are, for a particular thing to develop, there are multiple ways, there are multiple uh, technologies that are present in the market. So what they could do is they could say that, okay, let's try out this 2 or 3 options. Okay, first try to use this 2 or 3 option. Let's build something and then see whatever is better. So which option is better than the other ones, so we will use that particular thing for the development of the actual software. So as per the proposals, I mean, they could divide the team among themselves, and then those divided small teams can work on such ideation part using different like technologies. So that is developing the prototype. And once they have developed like 2 or 3 different type of prototypes using different technologies, they will evaluate that which one is better to use. Okay, and which is giving a better prototype, after the development of those prototype. So once that evaluation is done, after that they will select that, okay, we are going to use this particular technology or this particular tool for our development, and then the actual development will start.
Okay.
So this is kind of the background of this prototype model. So it might also happen that the initially they will use this prototype model just to develop the initial prototype, and after that they can choose any other model for the actual product development.
Mhm.
So it also helps understand the requirements which are user specific and may not have been considered by the developer during the product design. Okay, so what are the advantages and disadvantages of the prototype model? So it increases the user involvement in the product even before its implementation. So that's what we saw, right? We are developing the prototype first, which is not actually the actual software. And even before the implementation, that's what I was trying to make you understand, that even before we start working on the development, or rather it's the developers who start working on the actual implementation of the software, they are trying to look at the different options available, and they're trying to build a prototype out of those options, and then whatever is more feasible and more effective and more beneficial, so they are going to use that for the actual implementation of the software, right? So but even before the implementation is getting started, we are having those prototypes which we can show it to the customers as well, to the users. So their involvement is also getting started even before the implementation of the product is getting started. So is it clear?
Yeah.
Okay.
Yeah.
So since a working model of the system is displayed, the user gets a better understanding of the system being developed. This is also clear, I guess.
Yeah.
Okay. This reduces the time and cost as the defects can be detected much earlier. So yes, this reduces the, I won't say that reduces a lot of time. Obviously, yes. I mean, there are different perspectives. So it requires a time that has to be allocated in during the estimation, because when you are building the prototype, you are not building the actual software. So building the prototype would require some extra time, but at the same time, if you see that it reduces the time and cost, as the defects can be detected much earlier, because whenever you are developing the prototype, from there itself that what could be the possible defects that could come, right? Because you have the prototype and you are testing the prototype. So while you are testing the prototype, if it is having any defect, it will be caught and the developers will fix that. So overall it reduces the time and cost that the defects will incur you even before the actual product development is started. So overall, if you see, the defects are caught earlier and those are fixed earlier. So in the latter stage, when you actually test the application or you'll test the software, you get less defects there. And as you are getting less defects in the latter stage, so it will reduce the overall time and cost of the development of the whole software. Quicker user feedback is available, leading to better solution. Obviously, we are developing the prototype. Whenever this prototype is coming, this applies for all the cases, because we are getting the user feedback very soon. And as soon as we are getting the user feedback, we can also incorporate those in the next iteration, and that will help us to build a better solution. Missing functionality can be identified easily. This is also like uh, uh, common for all the prototyping models, because if we are missing any functionality and we are demoing the prototype to the customer, so if the prototype is missing any functionality, that could be identified by the customer, or it could be identified during the testing phase itself, and then those can be implemented in the next iteration. Confusing or difficult functions can be identified. The same thing, I mean, as like we are testing it, we are developing it in the iterations. So if there are any confusion or difficult functions, so that can also be identified during the development of that prototype. Now, what are the disadvantages? So the disadvantages, first disadvantage is risk of insufficient requirement analysis owing to too much dependency on the prototype. So there is a risk associated with it if the requirement is insufficient. So in that case, like, there will be too much dependency on the prototype, because see, try to understand it in this way, that if your requirement is insufficient, the customer is not clear with the requirement, then they will rely on the prototype, whatever you are building, right? Whatever prototype you are building, so they will look at that, and then they will think that, okay, so this is being developed in this way, we can put these things on top of this. So the requirement is not coming initially. What happens initially in the other, like in case of the waterfall model or the other models, the requirement was coming first, and those were the exact requirement, and on top of the using that requirement, we were building the software. But here what will happen is, if the requirement is insufficient, so they will first look at the prototype, and on looking onto the prototype, they will give you the next requirement.
Hmm.
Are you getting it?
Yes, yes.
Okay, so there is a risk associated with that. What is the next one? Users may get confused in the prototypes and actual system, because these prototypes are not the actual system. This prototype are just giving you some of the features, just to show you that, okay, the developers have the capability, or these are the different options through which we have developed the prototype, and we have found such and such issues while developing the prototype, and that's why we are going to use a particular technology to develop the actual system. Now, the users or the customers, they might get confused, that because when they will see a prototype, they won't understand, if they are not very much technical, they won't understand that, okay, whether it is the actual product or it's a prototype. Okay, so this might create some of the confusions. Thirdly, practically, this methodology may increase the complexity of the system, as scope of the system may expand beyond original plans. So this is also like when you don't have the fixed requirement, okay, and this is the human psychology. Whenever you are shown something, so you will think that, okay, if this could be possible, we can have this and that features as well in that case. Okay, so this will make the system more complex, and this will add more and more requirements, which may expand beyond the original plan. Suppose you have the plan of building a software A, but when you are looking at the prototype, you think that okay, we can add some more features into this as well. So this will actually increase the scope, and if whatever the original plan is, it might go beyond that. So that is one disadvantage. Then developers may try to reuse the existing prototypes to build the actual system even when it's not technically feasible. So what does it mean? So whenever a prototype, so I was telling you, right, that they will try different options, and whenever they are trying different options and they have built something out of that, they have built the prototypes out of that, and while they will actually develop the software, so they will try to use those prototypes. Okay, and even if, because those are already built, which somewhere looks like the actual product, so now if they try to use something from the prototype itself, from the options of the prototype, which is not technically feasible, so that might create some confusion.
But if that is what the customer wants,
Yes, but the customer, think it from the developer's point of view. The customer has their requirement. They are not going to see what kind of what kind of technology or what kind of tools you are going to use, right? So they need the final product. But from the developer's point of view, they have you know developed some of the prototypes, and now while developing the actual software, they might try to use some of the prototypes, existing prototypes. It's not like, so there are 2 3 prototypes that have been built. Now if they try to use everything out of there, so that might be affected from the technical feasibility point of view.
mhm,
So this could be a disadvantage. I mean, it's from the development end. Again, it's from the development end. If they are trying to reuse all the prototypes, okay, so it is not like, if you have found a prototype which you are going to follow for the actual development, then it's fine. But when they are developing 2 3 different prototypes, and from there something is fixed, that okay, we are going to use this particular prototype for the development of the actual software, but at the same time they are having 2 3 other options as well which are already developed, and if they try to use those as well, so the problem is there.
yeah.
So it might cause some of the technical feasibilities. And finally, the effort invested in building prototypes may be too much if it's not monitored properly. So when you are developing the prototype, so it might require a lot of efforts, and it has to be monitored properly. If you don't monitor properly, it might take a lot of time, because there are a lot of iterations in between. If you remember the diagram here, it has a lot of iterations in between, and if not monitored properly, these iterations might take a lot of time. Okay,
Mhm.
so that has to be monitored. So this is one of the disadvantage. So when we should use prototype model should be used when the desired system needs to have a lot of interaction with the end user, because we'll be developing the prototypes and then we'll showcase it to the customer, and based on the feedback received, we will develop further. Typically, online systems, web interfaces have a very high amount of interaction with end users, are best suited for prototype model. It might take a while for a system to be built that allows ease of use and needs minimal training for the end user. So, where we have this end user interactions, okay, so in those cases, or like the end user has to be trained a lot, uh, uh, based on the different features of the software. So in those cases, whenever you are giving these prototypes to the end users and they are using it, so they will also get trained, and they will need minimal training to understand and use that end software, because they are already looking at the prototype, and they have the basic understanding or some understanding of the software, or the working or the nature of the software. So in those cases, prototype model is a good option. And finally, prototyping ensures that the end users constantly work with the system and provide a feedback which is incorporated in the prototype to result in a usable system. So this is, I mean, similar. I mean, whenever you are showing it to the customer, demoing it to the customer, so they will provide you the feedback which you will incorporate in the next iteration, and that will give you a more usable system or a more bug free system. So these are the cases when you can use the prototype model. Okay, any queries?
No, by in saying end user meaning the client, right? The customer.
Yes. So
So
sometimes
it
the end user will mean as the customer. Sometimes it will be mean because the customer is also will be having their users, right? Because the customer is building it, and then that will be used by some of the user. So
okay.
like, if Amazon is the customer, so who is the end user? End user is
The,
not the Amazon. End user
yeah,
is
yeah,
us. We
yeah, yeah, yeah,
who are using the software. So those are the end
yeah.
user. Suppose there is
And
a banking company.
uh,
So in case of banking company, there could be different end users. So
mhm,
if we talk about the net banking, so for the net banking, the customers are the end users. But if there are any banking software which the employees of the bank are working or using, so in that case, the end users becomes the employees of the bank.
okay. One more question. I saw many advantages for this prototype. Does it mean it's a very popularly used one?
So see, as I mentioned, that it might happen that this is being used for the development of the prototype, just the development of the prototype, and after the prototype is fixed, you can go for any other model as well.
Mhm.
Like, so initially, like as I was describing it to you, that initially when you have got the requirement, so the developers might have several options, right, to do the actual implementation. So now they might need to work, or they might need to develop some of the prototypes using those different options, so that they know what is the best option that they can use
Mhm.
for the actual development of the software.
Mhm.
So at that time, what they will do, they will build a few prototypes using the different options that are available to them. And after that, they will come to a conclusion that, okay, this option is best for this software. So the proof of concept thing that we are talking.
Mhm.
So that's why, I mean, for any big projects where if the project is complex, so in those cases this is done by the developers. They try to build a prototype, and based on that, they start the actual development of the software. And
Mhm.
this can be integrated with the other models as well, like for the incremental model, or for the iterative model, or for any other model. You can first go to develop the prototype, and this prototype is also being developed in other cases as well, in the other models as well. This prototype is getting developed, right? So this
Mhm.
is somewhere common for all the other models as well. Don't take the waterfall model and the V model into consideration, because those are sequential model, right? So
Yeah.
this is not considerable for the sequential models. But for the other models, somewhere we are using the prototype model, and then we are actually using the other model. So that's why
Mhm.
it's having its own advantages, and that's why
Mhm.
it can be also integrated with some other models as well,
Mhm.
just to develop the prototype first, and then once you get the knowledge, or once you get the confirmation that which tool or which technology we are going to use, and we are also getting the initial feedback from the customer, then we can go to the iterations, and on top of the prototype we can develop the actual software.
Mm.
Okay, so we have completed the prototype model as well. The next one is the spiral model. Okay, let's take a small break of 5 minutes, and then we'll continue with the spiral model. Okay.
Okay. Mhm.
Okay, so before we start, I'll just show you the diagram. Can you see my screen?
Yes,
Okay, so just keep this for reference.
but
This
I
is the
can't see
diagram.
any. I can't see any diagram yet. Yeah, yeah. I got it.
Okay, so this is the diagram of the spiral model, and if you
Mm.
just remember this, that will be enough for you. Have you taken the snap?
Yes, I did.
Okay. 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 So what is a spiral model? So this is also similar to incremental model, but
Mhm.
there is a factor which is associated with this model. So based on that, I mean, this spiral model is developed, and whenever that particular fact is there, we will use the spiral model while as the software development model. Now this, as you can see in the diagram, this particular model is having mainly four phases. The first one is the planning phase, the next one is the risk analysis phase, the third one is the engineering phase, and the last one is evaluation phase. So the factor uh, that makes it different than the other incremental models is that the risk analysis phase. So it has a specific risk analysis phase associated with it, where on every iteration, because if you see the spiral, right, that is like the
Mhm.
iteration. You're starting from there, you are doing a round of the phases, and again you are starting from there. So it's basically similar to the iteration itself, right?
Mhm.
So but what we are doing it in each iteration, before doing the uh, implementation, or before doing the development, we are doing the associated risk analysis.
Mhm.
So if some of the risks are found during the risk analysis, then we'll go for the alternative solution. What could be the alternate solution? So it could be again an extension of the prototype model as well. Okay,
Mhm.
because we are doing it in an iteration, we'll develop a prototype, and when the prototype is produced, we'll check that what are the risks that are associated with the prototype, and
Mhm.
based on the risks that are associated with the prototype, we'll we'll go for the alternate solutions, and based on those solution, we'll again go for the development. Once that development is done, we'll do the evaluation, we'll do the testing of the prototype, and once it is tested, again we go for the next phase, which will be the planning phase for the next set of development.
Mhm.
So that's why if you see the diagram, it's in the spiral. It looks like a spiral, so that's why it is called the spiral model.
Mhm.
So the baseline spiral, starting in the planning phase, requirements are gathered and risk is assessed. So if in the interview they ask you that in which model the risks are assessed, so the answer will be spiral model.
Wow.
Whenever you see some associated risks are analyzed, it will be spiral model.
Mhm.
So this is the keyword. If you
Yeah.
hear somewhere that where in which model we do analyze the risks, simply answer it's spiral model. And
Okay.
if in the interview they will directly ask you that what is spiral model, so you can say that spiral model is a type of incremental and iterative model where there are mainly four phases, and in the second phase there is a risk analysis phase associated with it, where we do the where we do the analysis of the risk associated with the prototype, and if some risks are identified, in that case we will go for the alternate solution, and based on that the implementation and the engineering phase will be done, and the evaluation or the testing phase will be done, and
Mhm.
similarly we will go to the planning phase again until the final software is developed, right?
Mhm.
Okay, so the baseline spiral, starting in the planning phase, requirements are gathered and risk is assessed. Each subsequent spirals builds on the baseline spiral. So on the first spiral, that whatever is the outcome from that spiral, in the next spiral, that will be on the top of that, it will be developed. So it's similar to the prototype as well. Like we are developing the prototype, and then we are developing on top of that in the next iteration. It's also same here. The only difference is there is a risk analysis phase associated with it. That's it.
Mhm.
Okay, so in the planning phase,
Yes.
what we are doing, the requirements are gathered during the planning phase. Requirements like BRS, that is a business requirement specification, and SRS, that is system requirement specification. So one thing that you need to understand is what is the difference between business requirement specification and software requirement specification. So, or the system requirement specification. So business requirement specification will have the business details. What is the business requirement? Right? So say for the Amazon.com, what could be the business requirement specification?
What are the what are the different applications they need? What are the pages they need?
That will be system requirement specification. In the business requirement specification, they will tell you about the business that they are trying to do using Amazon.com. So their business requirement specification will say that the sellers should be able to add their product, the customer should be able to choose the products from there, and we should be able to sell our product online.
Mhm.
So this is their business requirement from the business perspective. That is their business goal, right? Using the Amazon.com. Now, when we'll come to the system requirement specification, we will go deep. So we will see that, okay, if the business requirement is that the seller should be able to sell add their product and sell their product, the customer or the end user should be able to search the products and buy the product, and finally we need to deliver the product. So what should be the different components of the system that should fulfill this business requirement? At that time you'll see, okay, we'll need a search page, we'll need a product specific page, we'll need the card and the payment thing, and from the seller end they should be able to add their product, and those should come to the customer according to their product search. So these are the system requirement specification. So that is the different from the business requirement specification. The system requirement specification is derived. Is that clear?
Yes.
And this is not something which is used only in the spiral model. This is applicable for all the models, including the sequential models as well. Okay. Yeah. So
Yes.
next phase is the risk analysis phase. So in the risk analysis phase, a process is undertaken to identify risk and alternate solution. A prototype is produced at the end of the risk analysis phase. If any risk is found during the risk analysis, then alternate solutions are suggested and implemented. So this is, I think, simple to understand. The next is engineering phase, which is similar to the development phase or like the implementation phase. And in this phase, the software is developed along with the testing and the end of the phase. Hence, in this phase, the development and testing is done. And finally, the evaluation phase, where this phase allows the customer to evaluate the output of the project to date before the project continues to the next spiral. So basically, it is uh, displayed to the customer. They will evaluate the prototype, and based on their feedback, the next spiral will start. Okay. Any queries from here?
No. No.
Okay. So the change advantages are like the similar, nothing new here. Changing requirements can be accommodated because in each spiral, you are showing it to the customer, and if they have any kind of changes in their mind, so those can be accommodated in the next spiral. Okay. It allows extensive use of prototypes because all the prototypes that we are developing, so we'll do a risk analysis, and based on the risks identified on that, we can suggest some other options as well, and based on the suggestions we can go to the development phase. Now requirements can be captured more accurately. This is like again the same thing, because in each spiral you are showing it to the customer, they're providing their feedback and the requirements, and those can be captured again. Users see the system early. Obviously, whenever you have the prototype, the users will be able to see the system early. And finally, development can be divided into smaller parts, and the risky parts can be developed earlier, which helps in better risk management. As we are doing the risk analysis, so we know what are the riskier parts of the development, and we can, if there are different modules and there is some dependency among them, right? As like we are seeing, if there are 5 modules in the application, there could be it is possible that some module is dependent on any other module, and until that module is developed, the other module can't be developed as those are dependent. So in these things can be analyzed during the risk analysis phase, and accordingly those can be answered, or according to that the development can proceed. Now what are the disadvantages of it? End of the project may be known early, may not be known early, because it's in the spiral model. So when the project will actually end, we might not know that, because new requirements would be coming, and based on that the development would be done, the risk analysis would be done. So when actually the product will end, the project will be end, that we might not know early. Not suitable for small or low risk project, and could be expensive for small projects. Obviously, I mean, here you can see, like, right, whenever we are doing these iterations and all, and if the project is small or there is very low risk associated with the project, then this additions of a particular phase could is not required actually, right? I mean, if there is no risk associated and the project is itself small, then there is no need to associate a risk analysis phase with that, right? So that's why it's not suitable for small or low risk project. The process is complex as risk analysis requires highly specific expertise. Obviously, if you are trying to do the risk analysis in the earlier phases, So in that case, it requires highly specific expertise. Then spiral may go on indefinitely. That is the first point that is there in the disadvantage, that this spiral may go indefinitely if we don't monitor it. And large number of intermediate stages requires excessive documentation, because see, if you are doing the risk analysis and if you find the risk, so all those things have to be documented properly. So this requires excessive documentation as well. Okay. So see,
Mhm.
I mean, again, I'm telling you, all these points are not required. You don't need to remember, all these points. You just need to know what is spiral model. So if they ask what are the advantages or disadvantages of spiral model, say that the advantage is, what is unique of this spiral model. What do you think?
The
What is
risk
unique about
analysis.
risk analysis? So your answer should have the word risk analysis. That's all. What is the advantage of risk analysis? We are doing an early risk analysis. So if there are a lot of risk associated with the software, those will get identified in the beginning, in the earlier stages, and then we can look at the options available, and based on that we can work
Mhm.
accordingly. So this is the
Mhm.
advantage. If they don't ask you the advantage and disadvantage, if they ask you what is spiral model, you can answer this. If they ask you about the advantage and disadvantage, you can answer this as advantage. And the disadvantage is also having, if we have a small project which is not having a lot of risk associated with it, then associating a particular phase for risk analysis would not be a good option. And this is one
Mhm.
disadvantage. And if, as we are associating the risk analysis, so this requires highly specific expertise. So that is also a disadvantage. That's all.
Mhm.
Okay, so you don't need to remember all this theoretically, and you don't need to remember all these points. That is not required. Okay, so when we can use the spiral model, so if we are having a budget constraint and we can't actually have uh, a lot of risk associated with the development, so then risk evaluation is important. Because if you if there are risks associated with a particular product or a particular project, and that you get to understand at a very later stage, so that will cost you more in terms of time, in terms of money. It will cost you more because you have started taking a particular approach, and you have done almost at the you are almost at the end of the development, and now you are seeing that okay, whatever things we have taken into account, that is not technically feasible. Okay, so
Mhm.
in that case you need to go back and start almost afresh, right? So that will cost you more. So it's better to do the risk analysis uh, at the earlier stages, so that you can minimize the risks associated with it. So if there is a budget constraint, then risk evaluation is important for that project. So for
Mhm.
medium to high risk project, obviously, if there is medium risks associated or high risks associated, so obviously you will go for the spiral model. If it's a long term project commitment, so then you can go for the spiral model. If it's a short term project, you can't go for the spiral model. Now customer is not sure of their requirements, which is usually the case. In that case also you can go for the spiral model, because in each phase, in the prototype model as well, if the customer is not sure with the requirement, you can choose that. But on top of that, if you have risks associated, so you can go for the spiral model. So remember the term risk analysis. So if you have the risk analysis in your mind associated with the spiral model, you can answer anything. Okay.
Mhm. Mhm.
Requirements are complex and need evaluation to get clarity. New product line which should be released in phases to get enough customer feedback. So whenever you are developing those different prototype, so you get the customer feedback, and significant changes are expected in the product during the development cycle. That is also the same, the requirements are changing, and if the requirements are changing and if there are associated risks, so you might need to go for some alternative solutions as well. So that is when that is expected in prior, so you can choose the spiral model. Any queries?
No.
Okay, fine. So the final topic of today, and uh, this is something which is mostly used in the software industry now, and I would say that this is new in the software industry, but this has been used in the other industries like the manufacturing industry or the other industries from long back. Okay, so this model is called agile model, and this is combination of both incremental and iterative model. Okay, and in almost all the projects, whatever company will join or wherever you go, they might ask you about this agile model, because most of the cases they're going to use the agile model. So they will ask you whether you know what do we do in agile model. So from the interview perspective, I will give you some more information which is not covered here. Okay, so you can take a note of those things. I'll tell you at the end of the thing. So just will move quickly because there is nothing new here. You almost know everything, so we'll focus on the points which are more relevant from the interview perspective. Okay, I think that is fine for you.
Mm-hmm.
Okay, so what is agile SDLC model? So this is a combination of iterative and incremental process models which focus on process adaptability. So the requirements, if there is changes in requirements, so that is handled here as well, because it's having the both iterative and incremental models. Obviously that will be there. And customer satisfaction by rapid delivery of working software product. So because I mean we have the iterative and incremental process, so we'll rapidly develop the product. It will go for the customer feedback, and based on that we'll keep developing it. Now agile methods break the product into small incremental builds. These builds are provided in iteration. Each iteration typically lasts from 1 to 3 weeks. So I will give you more relevant information regarding this. Okay, agile model believes so I will show you practically how this is done. Okay, so that will actually help you to understand the agile model so that you can answer it in a better way during the interview. So agile model believes that every project needs to be handled differently, and the existing methods need to be tailored to best suit the project requirement. In Agile, the tasks are divided to time boxes to deliver specific feature for release. So the Agile software development emphasizes on four core values: individual and team interaction over process and tools. Over the process and tools, it focuses more on the team interaction and the individual. Working software over comprehensive documentation. We document less and we focus more on the working software. So what we do, we try to develop working thing as soon as possible. Okay, and on the top of that the development goes on. So you have you're already having the idea that what is incremental model and what is iterative model. So in those two cases, like, we are trying to develop the builds as soon as possible. In incremental model, we are dividing the requirement into certain builds and we are trying to build those in parallel. And in the iterative model, we are trying to build the uh, software in an iteration so that we can have the prototype, we can show a working model of the software to the customer, and based on their feedback we are developing it. So it's a mix of both. So that's why it's we are getting the working software as soon as possible. And the customer collaboration is also there, because in every iteration we are showing it to the customer, we are getting the feedback from them and responding to change over following a plan. Over rather than following a proper plan, we are responding to the change. So whenever there is a change, so agile is known for that only. I mean, we are flexible enough to the changes of the requirement. Whenever there is a change, we should be flexible enough to incorporate those changes in the development. Okay, so that is the
Mhm.
agile model. So what are the advantages and disadvantages? The advantages is delivery of useful software. This is, I mean, uh, applicable for all. People and interactions are emphasized rather than process on tools. So in agile, what is focused more on is, rather than going on to the tools or like the process, what we follow is the interaction between different teams and the customer as well. So that's why you can see the customers, developers, testers are constantly interacting in between them. Okay, here in case of agile, working software is delivered frequently because in each iteration you will have something which is working, so you can show it to the customer. So in each iteration we have something that is working that we can demo to the customer. Now close daily cooperation between business people and developer. Okay, so on a daily basis we'll have some interaction with the customer or in between the developer and the testers. Continuous attention to technical excellence and good design. So continuously it is monitored. um, Regular adaptation to changing circumstances. As I mentioned, whenever there is a change, we try to adapt to the changes in the agile model. And finally, even late changes in the requirements are welcome. So whenever there is a change, we try to incorporate those changes. Okay, what are the disadvantages? In case of some software deliverables, especially the large one, it is difficult to assess the effort required at the beginning of the software development lifecycle. Because what happens in case of agile, what you need to remember is, in case of agile, we try to give a working part at the end of each iteration. At the end of each iteration, what we call here is sprint. Like each iteration is called a sprint here. So at the end of each sprint we try to provide a working software to the customer, right? Working software doesn't mean that the whole software will be provided. A working branch of the software, we try to demo it to the customer. Now at the very beginning it's very difficult to assess the effort required to provide a working part. Okay, so at the beginning it is difficult. There is a lack of emphasis on necessary designing and documentation. In case of agile model, we don't, as I mentioned, we don't focus on much designing and documentation. Rather we try to build a working software as soon as possible. Okay, and that's why there is more collaboration between the customer, the developer and the tester, because we're getting rapid feedback or rapid requirement, the requirements rapidly in the calls from the from the customer, and then only the developers or testers are trying to implement that. So there is a less scope for documentation there. Okay, the next one is, the project can easily get taken off track if the customer representative is not clear what final outcome that they want. So this is where the main disadvantage is also present. Like we are having the regular calls with the customer. So in the other cases, what was happening, like in the sequential processes, like models, like or in case of just incremental or this iterative model as well, we were getting a, say, a part of the requirement fixed from the customer, right? And on the top of that, if they were suggesting some changes, we are incorporating that. But here we are having a daily call, a daily interaction with the customer, and if the customer itself is not clear what the final product they want, daily they might change their requirement, and the project can easily get off track, right?
Mhm.
So that is one disadvantages that we are having. And only senior programmers are capable of taking the kind of decision required during the development process. Because see, on each day, on each call, uh, if the customer is giving you some feedback, giving you some changes, so in that case the junior programmers or the junior developers won't be able to incorporate those things, so the involvement of the senior programmers are required here. Okay,
Mhm. Mhm.
so these are the disadvantages. Now, when to use agile model, I think you probably already know that, like whenever the new changes are needed to be implemented, the freedom agile gives is to change the incorporation of the changes. So that's what the name also is suggesting. You should have that flexibility to incorporate changes whenever it's required. It can be the beginning of the project development, it can be the end phase of the project development, but new changes can be implemented at very little cost. To implement a new feature, the developers need to lose only the work of a few days whenever, because it's you are having that communication with the with the developer, with the tester, with the client on a daily basis. So whenever we are getting some feedback, so the developer can quickly change, because see, the changes won't happen on a daily basis, right? If the changes are happening on a daily basis, then there is a issue, so that can be incorporated. But as we are having the daily feedback call or daily stand up call, where the customers are also looking what we are actually developing, and if they are having any suggestion there, small suggestion there, that can be incorporated without losing a lot of working days. Now, unlike the waterfall model, in agile model, very limited planning is required. As we already told, that we are not doing a vast amount of planning. It's being done on each sprint or each iteration. So that will agile assumes that the end users need are ever changing in a dynamic business and IT world. So if their changes are coming frequently, so we can't plan accordingly. So we'll plan according to the situation here. And both system developers and stakeholders alike find they also get more freedom to time and options than if the software was developed in a more rigid sequential way. So obviously, I mean, if we are doing it in a sequential way, there is rigidity, right? Rather, if you are following the agile, it gives you a lot of space for the changes to be happened. So these are the theoretical thing that that is covered here, but I would like to show you what is actually practically done in the agile model. Okay, so what can you expect, what interview questions can you expect from the agile model? So they will ask you, what do you know about the agile model? So in the agile model, what is done is we follow different. So first thing is, theoretically you can say that it's a mix of incremental and iterative model. Okay, hello.
Mhm.
Yeah,
Yes, yes.
yeah. And then what you can, if it's possible, you can take the notes as well, or you can go
That's
through
what
the.
I'm doing. Yeah.
Okay, okay, fine. So in the agile process, the first thing that you can tell is it's a mix of incremental and iterative model. Each iteration is called as a sprint, and each sprint, the duration of each sprint is from 1 week to 3 week. So normally it could be 1 week to 3 week, and it's fixed for every team or every project. The duration is fixed, either it will be 1 week, or it will be 2 week, or it will be 3 week. What do we do in each sprint? In each sprint, this is an iteration, so at the end of each sprint we should have some working software which we can demo to the customer, and based on that they can provide the feedback. On a daily basis, we'll have a collaboration in between the customer, the business analysts, the developers, the testers, the management, so that we can get quick review and we can get quick customer feedback as well. Okay, and the next thing that you need to say are, there are different ceremonies that are followed in an agile process. I think we'll be talking about this at the end of our whole training, but as like we are covering agile now, I would give you some hints of that, so that at the when we'll discuss it further, we'll have those ideas. So what are the different ceremonies that are done on the first day of the sprint? The sprint planning is done, where we look that, okay, if we have this 2 weeks for this particular sprint, what are the different things that we'll be working on this particular sprint? So that will be done on the sprint planning meeting. After that, we will have a grooming meeting where the details of those works will be given to us. So what is basically, what do we do in the agile? A big project is divided into different user stories, and from those user stories, those are divided into different tasks. So these tasks are associated to each resources. Okay, so you just listen to this, don't need to understand anything. I will actually show you how these tasks look like, how these user stories look like, how this epic look like. So each, say, a big chunk of work, so that big chunk of work is divided into different user stories, and those user stories will be divided into different tasks which you can complete within 2 or 3 days. Okay, so it's basically
Mhm.
dividing the big task to smaller tasks. So this smaller task will go mix up, and it will give you the end product at the end of each sprint, right? So on the
Mhm.
daily basis, we'll have some daily stand-up calls as well, where we'll discuss about what we have done, and if we are have any risk associated with it, if we are having any blocker issues. So those we'll discuss on a daily stand-up call, which is a very small call of 10-15 minutes. And here actually the collaboration between the different teams, the development team, the testing team, the business team, the management, the customer, so the collaboration happens on a daily basis here. And at the end of the sprint, we'll give a sprint demo, whatever we have achieved, whatever working software we are having. So we'll give a demo to them, and finally we will do a retrospection on what did go well in the sprint, what didn't go well, and how can we mitigate those things in the upcoming sprint. So that is
Mhm.
overall practically what we do when we work on any agile project. I'll just
Mhm.
take 15 seconds and I'll show you. So this is my project, okay? And here these are the small tasks that are assigned to everyone. So this one is assigned to me, okay? So this one, you know, this is a sprint which is for 2 weeks, and I will work on this one. So see, I will start. So sprint has just started today. So this is to do. This I need to do in this particular sprint. So when I start working on this, it will go to in progress. Now, if the developers are doing something, they will go to code review and then build validation. Once that is done, that will come for QA. I mean testing. So that is everything QA. Then we will test these things. Then this will be go to acceptance, and this will at the end this will go to done state. Done means that particular task is fully completed. So at the
Mhm.
end of the sprint, all these tasks will go to this acceptance or done. Okay, and finally you will have a working software, right? Working part of the software. And on daily basis we'll discuss how far have we gone with this particular task, if we have any blocker, if we have any risk associated with it. And also the customers can also provide their suggestions or their feedback. So that is
Mhm.
overall how the agile looks like.
Mhm.
You can also, like, if you have not noted down all the different ceremonies, you can also search for the different agile ceremonies. Okay, if you search for like so this is very important uh, for the interview perspective, and that's why I'm taking some more time or emphasizing more on this particular topic, so that if in the interview they ask you, you will be able to answer it correctly. So see, the sprint planning, then daily scrum, then sprint review, retrospective, product backlog. Okay, so these are the different ceremonies that we normally have in a particular scrum. Okay, the iteration is called as scrum in agile. Okay,
Mhm.
so what you can do is you can search for different agile ceremonies and read about this, so this will help you to understand it better.
Okay.
So this agile is very important from the interview, I mean practical point of view, because most of the projects are going to use this only. Okay.
Okay.
So
Uh-huh.
that was all from today. Okay. I
Okay.
hope you don't have anything to ask at this point of view, but you can go back and go through the slides and go through the topics, and if you have any query, do let me know tomorrow and we
Sure.
can discuss on that. Okay.
Sure. Thank you so much.
Okay, then bye. Have a good
Bye.
night.
Uh-huh.
Yeah,
Thank you. Bye.
bye.